Welcome to Tech News Briefing. It's Monday, July 3rd. I'm Julie Chang for the Wall Street Journal, filling in for Zoe Thomas. Only 5% of the universe is made up of matter that we can see. That means there's an invisible 95% that scientists still don't really know much about. That part is referred to as the dark universe. Now, the European Space Agency hopes to change that.
5, 4, 3, 2, 1, ignition, liftoff.
Over the weekend, the agency launched a new first-of-its-kind telescope into space. Named after an ancient geometrician, the Euclid Space Telescope was built to study dark matter and dark energy. Here to tell us more about this telescope is WSJ science reporter Aylin Woodward. Aylin, tell us more about this telescope. What exactly makes it so special?
So, unlike NASA's James Webb Space Telescope, which launched in December of 2021, Webb is designed to look very, very closely at individual cosmic structures, like very, very deeply at one thing. Imagine a hyper zoom on a camera. The way Euclid is designed is Euclid is a survey telescope. So you're thinking like wide view. Think of a panorama, but except instead of the edges of the panorama being blurred and out of focus, the entire wide image is in focus. So Euclid is designed to take in huge swaths of the sky at the same time. In fact, NASA currently has a Hubble Space Telescope orbiting Earth, and Hubble tries to do the same thing that Euclid is going to do, except Euclid can get done in 6 years what it would take Hubble 1,000 years to do, according to some mission scientists. And that's what makes Euclid so special, is that it's going to be able to observe billions of galaxies. And by increasing sort of the galaxy sample size, it helps scientists utilize observations from those galaxies to understand more of what's going on in our universe.
What kind of technology is in Euclid that allows it to do these things, like take that big panoramic picture?
So Euclid's goal is to use some of the biggest cameras ever sent into space. And Euclid's trying to sort of create the largest three-dimensional map ever. And it's going to be taking in 36% of the sky, which is absolutely wild. And some of the billions of galaxies that it's seeing are as far away as 10 billion light years. And the way they sort of are hoping to achieve these scientific objectives is that Euclid has both an optical camera and then a near-infrared instrument. And those two instruments are working in tandem to create these images. And then each of those images is going to have a 600 million pixel resolution. So that's like more than 12 times larger than anything produced by like the highest resolution Apple iPhone. And so that's a lot of data.
Real quick, can you explain to us what dark matter is and what dark energy is?
Dark matter takes up most of the mass in the universe, and it's sort of what is holding everything together. It's what allows matter to clump in the form of galaxies and things like that. So dark matter is sort of this great puller together. And then dark energy is almost its opposite. Dark energy is what's pushing things apart in our universe. And it's actually what scientists think is responsible for our universe expanding at a rate that's accelerating. So our universe, since its birth during the Big Bang, like 14 billion years ago, roughly, has been expanding. But roughly 6 billion years ago, that rate of expansion sped up. And scientists aren't sure why. And they think right now that it has something to do with the increasing effect of dark energy on the universe, but they're not sure. And so by studying dark energy and dark matter, it's going to basically help determine the fate of the universe, which sounds like an overstatement, but assuredly isn't, according to many experts.
Okay, to dive a little deeper here, so we're looking at these galaxies. How does that help us study dark matter?
So dark matter doesn't emit or absorb light, so you can't detect it using traditional telescopes. The only way you can study it is indirectly, by observing the effects of dark matter's gravity on other objects in the universe. And so for each of those billions of galaxies that Euclid is looking at, scientists are able to sort of see how the light and shape of the galaxy gets distorted by the dark matter between that galaxy and Euclid. And because the sample size is so high, because there are so many of these galaxies that Euclid will be looking at, they're able to suss out the pattern, the amount and distribution of the intervening dark matter. And then by better understanding that distribution, scientists can understand sort of how the universe is expanding over time. And that should give them more insights into dark energy and dark energy's effects. Scientists, like their best theory right now is that due to dark energy, the universe will keep expanding faster and faster and faster until the point where everything in the universe dies a lonely death many billions of years into the future, like very far apart from each other. But if data from Euclid reveals that our understanding of dark matter and dark energy is incorrect, and maybe dark energy is a little bit stronger than we think, the future of the universe could be that one day galaxies get ripped apart, stars get ripped apart, planets get ripped apart, even atoms get ripped apart. And that's sort of the ultimate fate of our cosmos.
Okay, so the telescope launched over the weekend. Where is it headed and how long will it take for it to get there?
So Euclid's going to make a 30-day journey to an orbital perch about 1 million miles from Earth. It's actually going to the same sort of orbital point in space that James Webb is at right now. And at that point, it's going to be orbiting the sun once a year, sort of in lockstep with Earth.
And how will this telescope work with James Webb?
NASA's James Webb Telescope, again, was designed to look very deeply at individual things in the universe. And so the way these two telescopes can work in tandem is Euclid's able to look at, again, a really broad swath of the sky. And so it's able to spot things that are rare. And so if Euclid spots something weird, scientists can flag that and then go to the mission operators at Webb and say, hey, can you look more closely at this thing that we think is rare and odd and we want to understand better?
All right, that was our science reporter, Aylin Woodward. And that's it for today's Tech News Briefing. A quick programming note, we'll be off tomorrow for the holiday, but we will be back on Wednesday with more tech news. And as always, if you want more tech stories, check out our website, WSJ.com. I'm Julie Chang for the Wall Street Journal. Thanks for listening.